Okay, welcome Math 110. This is another video lecture. This is the video lecture for Wednesday, April 1st. And on Monday we talked about population growth, and we're going to continue to talk about population growth. So the topic is population growth. And if you guys recall, populations generally grow exponentially, okay? And so we can model population growth with an exponential equation, p equals p0 e to the rt. Okay, that's the basic equation we use. In this equation, p equals the future population, p0 equals the initial population, okay, r equals the growth rate of the population, and t equals the time. Okay, this is an exponential equation of the growth of a population, and we're going to consider an example together. And the example relates to the U.S. population. Okay, the U.S. population in the year 2000 was 282.2 million. In the year 2010, that population was 309.3 million. Okay, that's actual census data. And the first thing we want to do here is we want to figure out the growth rate of the U.S. population. So what is the growth rate R of the U.S. population? We're going to use this census data to do this. And the way we can use this census data is we can make the year 2000 population be our initial population. So our initial population, P0, equals 282.2. Okay. We're going to use we're going to call the future population our 2010 population. So the future population is 309.3 million. Now keep in mind, 2010 is not in the future, it's in the past, but for the sake of figuring out the growth rate, we can make this be our future population. We can use this equation now. So our future population is 309.3. I'm not going to write the million to save some time. Our initial population is 282.2 million. Then we have E. We don't know what R is. Now here's the thing, what is T? Well, T, if this is our future population and this is our initial population, our T is 10 years because this is 10 years in the future. So we have an R here, and we don't know what R is, and we have a 10. And now we want to solve this equation for R, for our growth rate. The first step is, as you guys should know by now, you divide both sides by 282.2. Okay, and that leaves us with, these cancel out. 309 divided by 282 is actually 1.096 equals e to the 10r. Okay? So if we divide by 282.2, we get 1.096 equals e to the 10r. Okay, now we want to solve this equation for r. And as you guys hopefully know by now, the standard approach is take a natural log. So we take a natural log of 1.096 of both sides of this equation equals natural log of e to the 10r. Okay, and we're going to use this power property, which says if we take the natural log of something raised to a power, we can bring this power in front. So this will equal 10r times natural log of e. Okay? And the natural log of e is just 1, so that goes away. So now we have this equation 10r equals natural log of 1.096. Okay? We want to solve this equation for r. So our final step here is to divide both sides by 10. We get r equals 1.096 divided by 10. Okay? And that equals, if you guys plug that in your calculator, that equals 0.00 or that's equal to 0.92%. Okay, this is our answer. So what that's telling us is the U.S. population is growing by 0.92% per year. Okay, so we're basically applying this equation, this exponential growth equation, to the future, to the population growth of the U.S. We're using census data we've taken for the United States. We're determining what the growth rate of the U.S. population is, and we've determined that R is 0.92%. And we did that by using this equation and using this census data, calling the population, the year 2000 population, our initial population, calling our future population, 309.3 million, 2010 population, our future population. We know that because there's 10 years in between these two populations, our t is 10. The only thing we don't know is r, and then we basically can solve this equation for r by taking a natural log of both sides. Okay, I want to do one more part of this problem to show you guys something else that's neat. So I'm going to erase this here. Still the same example, however. And we're going to do another part of this problem. Using this information, we want to figure out what is the U.S. population, what is the population in 2030, or what will the population be in 2030 for the U.S. population. Now keep in mind we just determined our growth rate for the U.S. population, 0.0092. That's our growth rate, okay? So we want to figure out what is the population in 2030. Okay. The way we do this now is we can still keep our initial population. If you guys remember, our initial population was, what was it? 282 million. 282.2 million, that was in the year 2000. Okay. But now we want to figure out our future population. We don't know what our future population is. That's P. So we write P there, and our future population will be equal to our initial population, which is 282.2 million, times E to the RT. Now we know our growth rate is 0.0092, okay? And the question is, what is our T here? Well, the year 2030 is 30 years in the future from our initial year of 2000. And so in this case, our T is 30. Because 2030 is 30 years in the future from year 2000, which is the initial population we're using. So we plug in T equals 30. Okay, we can simplify this. And if you guys plug this in your calculator, you get 371.9 million. Okay, 371.9 million. Okay, and that's the population of the U.S. In the year 2030. Okay. I want to do one other part of this problem. If we could ask ourselves, how long does it take for the U.S. population to double? How long does it take for the U.S. population to double? Okay, and let's do this part. So in this case, if the population doubles from 282 million, right? That means that our future population P will equal 2 times 282.2 million. Okay, and that actually equals, what does that equal? That equals 32, that equals 564.4. I did the math on that, right? 564, because 250 would be 500, that worked, 564.4 million. And when the U.S. population doubles, that'll be the population. Our initial population is, our initial population we can use as being 282.2 million. Okay, and now we can use our equation. So we have 564.4 equals 282.2 times E. Now we know our growth rate is 0.0092. We don't know the time though, so we get 0.0092 times T. Okay, we're looking for how long it takes the US population to double. First thing we can do, we want to solve this equation for T. We divide both sides by T. Divide both sides by T, and that leads us to this equation. These cancel out. This is 2. We get the equation 2 equals E to the 0.0092T. Why is this 2? Because by definition, 564.4 is 2 times 282.2, so 1 divided by the other is just 2. And then we have to solve this equation. And if you guys are thinking, take a natural log, you're right. We take a natural log of both sides. Okay? This is what we get. Alright? And then we can pull this power in front like we always do. Okay, natural log of E is 1, so that goes away. So now let me go up here. We have this equation. 0.0092T equals natural log of 2. The final step here is we want to isolate T, so we're going to divide both sides by 0.0092, and we get T equals natural log of 2 divided by 0.0092. And then I have to confess to you guys, I need to go grab a calculator. I'll be back in about 5 seconds. Okay, and if we plug this in, we get 2 natural log of 2 divided by 0.0092, and that comes out to, T comes out to 75.3 years. Okay, 75.3 years. So it takes the U.S. population, at this current growth rate, it will take the U.S. population 75.3 years to double in size. Okay, 75 years. That's assuming the growth rate remains the same. The growth rate will probably decrease, so it'll take longer to double than that. But that's how long it will take the U.S. population to double. So that's all I'm going to do for this video lecture. Basically, let's just review this idea again. We're still doing population growth. Population grows exponentially. This is an equation we can use to model that growth. P equals P0 times E to the RT. P is the future population. P0 is the initial population. R is the growth rate. T is the time. And then we can do some fun things with that. We can use actual census data from the United States, and we can determine the growth rate R. We can determine what the population will be in 2030, and we can also determine how long it takes the U.S. population to double. Okay, well that's it. I will post that on YouTube, and I look forward to seeing you guys on Wednesday. All right.